This is problem 3 on exam 1 of module 6 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 3 is 3 resistors are connected as shown, A, B, and C, in a triangle. The battery is connected across 3 possible positions, 1 and 2, 1 and 3, and 2 and 3. When the battery is connected across 1 and 2, resistor A draws a fifth of an amp. When the battery is connected across 1 and 3, resistor A draws a seventh of an amp, and when the battery is connected across 2 and 3, it draws a ninth of an amp. What are the values of the 3 resistors? Ooh, this is a good one. We got the voltage of the battery is 12 volts, and we know the current through resistor A for each of the 3 possible configurations. What do we do now? Well, let's put the battery there and start calculating. We'll put a battery across 1, 2. There it is. It's given that the current through this resistor, resistor A, is a fifth of an amp, 0.2 amps. The voltage drop across A is clearly 12 volts. The resistance of resistor A must be V over I, 12 volts over a fifth of an amp, that's 60 ohms. That wasn't so bad. Now we hook it up across 1 and 3. In this configuration, resistor A draws a seventh of an amp. So what? What can we do with that? Pause the video and think. The current going through this is a seventh of an amp. Figure it out for yourself. What a great opportunity to develop your problem-solving ability. How does this help? What about the voltage drop across resistor A? We know it has a resistance of 60 ohms. We just calculated it. It's given that the current is a seventh of an amp. The voltage drop across resistor A must be seventh of an amp times 60 ohms, 67 volts. What is that? 8.8 4/7 volts? What can we do with that? How does that help? Another opportunity to think and pause the video. We know the voltage drop across A. We know the current through A. So what? Think. What can we do with that? So, do we know the voltage drop across resistor C? Well, we know the voltage drop across the points 1 and 3 is 12 volts, the voltage of the battery. So the voltage drop across resistor A plus the voltage drop across resistor C must be 12 volts. We also know the current through resistor C must be a seventh of an amp because that's the current through A. There's only one pipe here. The current through A has to be the same as the current through C. So, the voltage drop across C is 12 volts minus the voltage drop across A. We can get a common denominator of sevenths. 84 over 7 is 12, so we can get 24 over 7 volts for the voltage drop across resistor C, 3 3/7 volts. The current is also a seventh of an amp. Got to be the same as resistor A. So the resistance of resistor C, we know the voltage drop, we know the current through it. The voltage drop is 24/7 of a volt. The current is a seventh of an amp. That's 24 ohms. Okay. Great problem. Almost done. One more to go. The final configuration is across 2 and 3. Like that. What can we do with this? Resistor A gets a ninth of an amp in this configuration. We know the resistance is 60 ohms. It must have a voltage drop of 60 over 9 volts. Resistor B must get the same current. Whatever current's flowing through A has to flow through B. There's no other branch. We can calculate We can subtract 60 over 9 from 12 to get the voltage drop. 108 over 9 is 12. We subtract that from 60 over 9, we get 48 over 9. We know the voltage drop across resistor B. The current must be 1/9 of an amp, the same as resistor A. So the value of resistor B must be 48 over 9 divided by 1/9, which is 48 ohms. We have the three resistors, our A 60, our B 48, and our C 24. If you're so inclined, you can calculate the current through each one of the three resistors in every configuration just to make sure you understand exactly what's going on, and calculate the voltage drop across at any path from one side of the battery to the other, this one or this one. It should be 12 volts. You can calculate the equivalent resistance of the entire circuit in all three configurations and make sure it's consistent with V is equal to IR for the battery. What a fun problem. There's a lot more you can squeeze out of it. Don't be in a hurry to go to the next one. A lot of thinking, not too much calculating. That's what I like.